Right directly on the table, right?
Just one.
Just a couple pieces of paper. Now remember, I'll videotape our math, just like last year.
Do I get like notifications?
Are you connected to the Algebra I Facebook page, Facebook group? Is everyone on the Algebra I Facebook group? Then send me a message. Connect me to the Algebra I Facebook group. If you're not in the Algebra I Facebook group, send me a message and ask me to send you an invitation. It's a private group, secret group. You can't see it until you're invited to it, so no one can see that you're in it. And just because it's, we don't want people trolling for who's in what class. Send me that. I post the link to the video in that group. Bless you. I'm not going to make the video public. I'm going to post the link to the video in that group, and that's where last week's video is. In that group, there's a link to the video. You click on that link, and you watch the video. Okay, Cash. Okay, so Cash, we're doing we're having a quiz here. So you're going to put your name, you're going to put the date, and then you're going to put Algebra I quiz. Now remember, in this order, top left-hand corner, one under the other. Not across the top, right? One under the other. Why am I doing this? Why am I being so OCD about this? Guess where you have to do this? College. Right. I could care less where you put your name if it's on there somewhere, but in college, you're going to have to do this, so I want you to start getting in that habit. Make sure I write this down right. Say it again. Oh yeah, you can use your calculator. Who are you and what did you do with Sullivan? Look at you going to town there. I'm proud of you. Does everybody have both questions? Write both questions then? Who doesn't have both questions? Write both questions down for me. Oh, hit it. Give it to me out though. Oh, I don't want to erase that, but anyway. Okay, 2 more minutes. Okay, I'll pick them up. if you're struggling with this, get with me.
Miss Cora, I think this is your paper too.
Say it again.
I think this paper.
Oh, I left that. Thank you. Did I get it? Oh, Miss Allen. That's okay, we're gonna go over it, and if you're having trouble, we're gonna go over it here. We're gonna review it again very quickly. These are the two main concepts that we've been working on this past week, okay? If you still have trouble, then get with me. Now, if you haven't finished your homework and watched the video, don't call me yet. If you did not do well on this, you need to watch the video from last week. It's on our Facebook group. We need to finish your homework, right? Finish your homework from last week. And if you have questions after watching the video and you can't finish your homework, then let's get together. But you have to do your part first, okay, of watching the video, reviewing what we did in class. Now, the formula for this is the cardinality of A, the number of elements in A, plus the cardinality of B, the number of elements in B, minus the cardinality of A intersection B, minus the number of elements that they have in common, and that equals the cardinality of A union B. That's the formula. You have to memorize that formula. I gave you the cardinality of A. The number of elements in A is 12. Here we have a plus sign. I gave you the number of elements in B. The cardinality of B is 21. We have a minus sign in our formula. Then I gave you the number of elements that they have in common, that the two sets have in common. The cardinality of A intersection B. The number of elements they have in common is 7. And that's going to give us our answer. 12 plus 21 is 33. Minus 7, is that 26?
Yes, ma'am.
Very good, 26. Then you just do 12 plus 21 minus 7 in your calculator. Does everybody remember that now? You have to, the key is to memorize your formula, huh?
So sorry, the A intersection B, I get that, and the A
Union B.
union.
How many members? If I have a club, Club A has 12 members in it.
Right.
12 of y'all are in Club A. 21 of you are in Club B. But of that 12 and 21, here, there are 12 people in A. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, now here is Club B, and there are 22 people in Club B. Pretend like that's 22 altogether. 7 of them are in common. 7 people that are in Club A are also in Club B. That's the intersection of Club A and Club B. A has 12 people. B has 21 people. Did I say 22? I meant 21. B has 21 people. But of that, 7 of the people are in both clubs. So now, what is A union B? How many people are there all together?
21.
No, there are 21 just in Club B.
Oh, okay.
How many people are there all together in A and B? And here's the formula for finding that. The formula for finding the number of subsets, the cardinality of C is 5. There are 5 members in set C. 5 elements in set C. Did you forget the formula for that?
No, I just forgot what a subset was, and my mind drew up.
2 to the n. What is n the number of elements? 2 to the 5th, and 2 times 2 times 2 times 2 times 2 equals 32. Yes, ma'am. Oh, you don't have to write the formula. I'm just showing you the formula to remind you of why this is the answer. and then that. But you don't have to write the formula out. Any questions about that? Does that make sense? Does some of you have trouble remembering those formulas? If you did all of your homework, you should not have had trouble remembering it. You should have enough practice. And so once I look at these tests, if I see that you did not do well on it, the first thing I'm going to look at is, did you get your homework done? If you got your homework done, then that's going to suggest to me that I'm not giving y'all enough homework. But you do have to study your homework also. Remember, you do your homework, but you need to study it also. You can't just whip it out the first couple of days and then not look at it again. You have to study it. You have to do it and then remember it. Like studying for the test. Okay, so now we're going to finish up chapter 1 today. It's funny. Vincent's brother Sawyer graduates this December, and he forgot about radical numbers. He's going back and taking this math that he has to get done to graduate. And he and I worked on this not too long ago. And so my point is, you need this for college. This is a very important concept here. Okay, so starting on page 18, this is called a radical sign. I've written these notes for you so you can read along and pay attention without having to write some of it down. We're on page 18. This is called a radical sign. This is a symbol. It's called a radical sign. It stands for square root. Square root. If I have this written down, the way I read that is the square root of 16. The square root of 16. Now, the number under the radical is called the radicand. 16 is called the radicand. Whatever the number is, that's under the radical sign. It's not imperative that you remember the names, but I want you to hear them. I'm not going to test you on the names of these things, okay? But it is a good idea to be familiar with them. The radical sign poses the question, what number multiplied by itself equals this number? So, what is the square root of 16? It poses the question, what number times itself equals 16? And of course, that's 4, because 4 times 4 equals 16. Now you have a radical sign on your calculator. Punch in radical sign 16, enter. Where's your calculator? Where's your calculator? Is that a phone? We do not use phones. Do not pull a phone out. What are we supposed to bring to math class? Take out your phone and text your mom and tell her, so I don't have to text her, that you did not bring a calculator to class. Where's your calculator?
I didn't get one.
Text your mom and tell her right now you have to have a calculator for class. You have your phone with you?
Yeah, I got my phone.
Take your phone out and text your mom that you have to have a calculator. So yeah, so that's what I want to make sure that you can find it. These are the best ones, these TI 30s.
I like to paint too.
Look at the x squared right here. Does everybody see the x squared on this one? Where my finger is right here? Everybody see that?
You have to press second first.
Yes, you have. Right above it is a little radical sign. You see that? So press second, then press that button, and it gives you the radical sign. Now, so you're going to press second, x squared, 16, enter. So you're going to press that second button in the top left-hand corner. Then you're going to press the x squared button, because right above it is the radical sign. And the second button says, take this one, not this one. Has everyone found the radical sign? Share it with him. Has everyone found his cash? You found the radical sign?
I don't have my calculator.
Text your mama.
I mean, it's just lost if I have. So.
Text your mama that you have to find it. And I have some extras, but because yeah, and I bought some this summer. I bought a bunch this summer, but because of the move, I haven't gotten completely organized yet. And I think they're at home in my summer school bag. I keep looking for them like they're here, but they're not here. So you're going to press the second button, then you're going to press the x squared button because it has the radical sign underneath it. Then you're going to press 16, and then you're going to press the enter button. And what you should get, yes sir?
Whenever I do the second then squared button, it says error.
Let me check and see.
Because you're hitting with the X.
Let's clear it. Where's your clear? This is a TI-30.
My thing was covering
That's a long thing. So when I press second, oh, you see yours is different.
Yeah, that's what
Here's your square root button. Okay, you see the radical with the X? Okay, so let's see. So yours is different. This is why we're doing this, because the different people's calculators work differently. Here, you're going to put your radical in first, and then you're going to press that button to take the square root. Does that make sense? That's how you find the square root on your calculator. Make sure Nick's works differently. Make sure you're getting the answer of 4. You have to know how to use your calculator here.
Mine's different.
Hold on just a minute. So what you're going to have to do for yours is you're going to press, I think, 16 first. You're going to put the radical in first. Then, say it again. Yes, and then you're going to press that button. Nope, that's not how you're going to do it. You're going to press that button, then you're going to put 16 in. Then you're going to press it. No? Okay. So for yours, you're going to press your radical button. You're going to put in your radical at 16. You have to close your parentheses. You see how I closed it right there? Then you press enter. And it'll give you the answer. You have to close your parentheses. Anybody else have trouble getting 4? Everyone got that? So now, let's take a look at number 70, 71, and 72. The square root of 9 equals what?
3.
That's right. The square root of 9 equals 3. And you see it says because 3 times 3 equals 9. Fill in those blanks. The square root of 9 equals, and you're going to put 3. Because, and then you're going to fill in 3 times 3 is what equals 9. That's number 70. Number 71, the square root of 25, Nick, equals what? 5. That's right, 5, because 5 times 5 equals 25. Hunter, number 72. The square root of 10, I'm sorry, put the square root of 10 in your calculator and tell me what you get.
3.162277.
So that's enough. We'll go to 2 decimal places. 3.16, and then it goes on forever, doesn't it? Really, I only need 3 dots there. It's a never-ending, never-repeating decimal because there's no even number, there's no whole number that you can multiply by itself that will equal 10. That's very important to understand. So, now let's take a look at the list, starting with number 73.
Miss Lily,
Yes.
when I typed it in my calculator, I got 10.
Do it again. You have it on a different mode.
It worked. Yeah, it worked for those.
There you go. You're welcome. So now you're going to have to memorize these. What do you think the square root of 0 equals?
0.
0. The square root of 1?
1.
1. The square root of 4?
2.
All the way to 225. It goes in order. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. You have to memorize 73 through 88. You will have a test on this next week, and you will not be able to use your calculator for it. You have to memorize 73 through 86. Now you have some practice at the bottom of the page. That's to help you memorize it. That's some homework to help you memorize it.
Will they be the same exact thing?
I'm not sure I understand your question. Ask it to me again.
Will they be the same exact
Will they
question?
be the exact questions? As in, like,
These.
yes,
I will ask you some of these.
ma'am. Okay.
This is 1 through 15.
Yes, ma'am.
You have to memorize these. I might ask you this one, and that one.
I know. Okay.
There are no other ones
I know.
because the square root of 3 is not an even number. You're memorizing the even roots.
Okay.
Does that make sense?
Yes, ma'am.
They used to do that whenever I was in public school. We used to study something, and on a test, it would be something.
Oh, I know. No, we're not going to do that. Okay, so does everyone understand page 18? And what we're doing on page 18? Okay, let's go to page 19. Now, all numbers, all radicals that aren't equal to a whole number are never-ending, never-repeating decimals. And these are called irrational numbers. So, the square root of 0 is 0. The square root of 1 is 1. These are rational numbers. The square root of 2 equals what? Punch that into your calculator. The square root of 2.
1.41.
1.41 ... That's an irrational number. It's a never-ending, never-repeating decimal. A never-ending, never-repeating decimal is an irrational number. Punch in the square root of 3. Madeline, what do you get? The 6. Go ahead.
1.732.
1.73 ... That's an irrational number. It's a never-ending, never-repeating decimal. Allie, how about the square root of 4?
2.
That's a rational number, isn't it? That's a rational number. 2 is a rational number, so the square root of 4 is a rational number because it equals 2. Maxwell, you use that calculator. What's the square root of 5, Maxwell?
2.23.
2.23. Is that rational or irrational?
Irrational.
Irrational. ... It's a never-ending, never-repeating decimal. Sullivan, without putting it into your calculator, is the square root of 6 rational or irrational?
No, irrational.
Irrational, that's right. Irrational. Gabe, what about the square root of 7?
2.64.
Is that rational or irrational?
Irrational.
Irrational? Yes, you're irrational. Hunter, how about the square root of 8? Rational or irrational?
Irrational.
Very good. Noah, how about the square root of 9?
Irrational.
Why? Punch it into your calculator. It's rational, yeah. Because 3 times 3 equals 9. It has an even square root, or a whole number square root. Not an even number, but meaning not a decimal. So that was the what about the square root of 10, Matthew? Rational or irrational? Irrational. How about the square root of 11, Zach?
Irrational.
Square root of 12?
Irrational.
Square root of 13?
Oh, rational.
Rational? What are you saying? Rational?
Irrational.
Irrational, that's right. Square root of 14, Cash?
Irrational.
Square root of 15, Sarah? Square root of 16, Madeline?
Irrational.
Square root of 16?
Oh.
Rational or irrational? Punch it into your calculator.
Oh, rational. That's right.
4 times 4 equals 16, so it's rational. Square root of 17, Allie.
Irrational.
Square root of 18, Max.
Irrational.
Very good. I think you ought to get the idea, right? It's irrational if it's anything other than one of the ones we're going to memorize. One of the ones that comes out to a whole number, square root of 16 is 4. It's rational. Square root of 17 is a never-ending, never-repeating decimal. If it's not one of our even ones, one of them that comes out to a whole number, then it's irrational. So look at numbers 105, 106, and 107. Fill in those answers. Use your calculator. Sullivan, what'd you get for 105?
3.32.
Everybody agree?
Well, it says round to the nearest hundred.
Yes.
And what was your answer? 3.32 what? Put square root of 11 in your calculator.
It was originally 3.31.
Hold on. Put square root of 11 in your calculator and give me 3 digits.
3.316.
316.
It's over 5, so you add 1 to it, so 3.3.
Rounding to the nearest hundredth. We look next door, 5 or above, so we add 1 here. 3.32 is correct. Remember, we're rounding to the nearest hundredth place, so we look next door. Gabe, what's the answer to number 106?
2.65.
2.65. Everyone agree?
Yes.
What do you think? You agree? Okay. You're confused?
If you have the 5 and it'll bring the
Put
5
it-
would bring the 4.
Hold on, put it, because this doesn't mean anything to me. Put square root of 7 in your calculator and tell me the answer.
2.645.
645.
And but when the 5 would bring the 4 up to a 5. Wait. But with the
We look next door. This tells me to add 1 here.
but wouldn't the 5 wouldn't bring the 6 up. Would it?
Oh no, we're not involved with this. We're rounding to this place value.
Okay.
So if this is 5 or above, we add 1 here. It doesn't do anything over here.
Okay.
And so 2.65. Does that make sense?
Yes, ma'am.
Very good, very good. We should practice rounding. Hunter, number 107.
3.87.
3.87. Does everyone agree?
Yes, ma'am.
Very no.
I got 3.9.
Okay, so put in square root of 15 in your calculator again and see what you get. 3.872. 3.872. We're rounding to the nearest hundredth. So we look next door. That's 4 or below, so we ignore it and leave this the same. Right? Very good, very good. Now, we can never take the square root of a negative number. The square root of a negative number is called an imaginary number. There's no number times itself that equals negative 16.
What?
4 times 4 equals 16. Negative 4 times negative 4 also equals 16. 2 negatives equal a positive, right? There is no number times itself that equals negative 16. Does that make sense? Now, we can have the negative square root of 16. This equals negative 4. Negative 4. You see the difference between these two? We can't have the square root of a negative number, but we can have the negative square root of a number. Does that make sense? So now, 108 through 122 is what we just did in class. Now let's take a look, except we added imaginary numbers here. A rational number, the symbol for a rational number is Q. That stands for quotient. Okay? The symbol for an irrational number is P. I don't know what that stands for. And the symbol for an imaginary number is a capital I. So now, Noah, what is number 108? Rational, irrational, or imaginary? Are you going to put Q, P, or I there? P is correct. Very good. 109, Matthew, what are you going to put there? Q, P, or I?
It's rational, so Q.
Yes, that's right. It's rational. What is the square root of 36, Matthew?
3.
6? 6 times 6?
Yeah.
There you go. Zach, number 110, are you going to put Q, P, or I? I is correct. Very good. It's an imaginary number because there is no such number that there's no number that is the square root of a negative number.
Anything in the negatives is an imaginary.
That's right. Anything there is an imaginary number. Now let's go to page 20. Let's take a short break. It's almost time, and I'll clean the board off. So it'll be a good time to take a break.
If you can go home with them, oh yeah, if your mom says so, yeah. Yes, I'm just gonna have them do that.
What's wrong, Max? You leaving? He's one dead. Miss Lori, write down the algebra 2 homework and I'll give it to him.
He's gonna watch the video.
Max, where's he gonna bring you? That's what he's saying.
So you get
Yes. He started it. No, he's not the one doing what you're doing. Where's my phone?
I'll let you have it.
Max, give me my phone. You don't got it?
I ain't got it.
I really don't have it.
Where's Austin at?
He's in Mississippi.
He's sick.
Uh-huh.
Do you believe that, Miss Lori?
He's in Mississippi. He's fishing. That's what he's doing.
He just said 6 days and he posted a picture
He's
of him on his
sick of
boat.
being at school. That's what he's doing. I don't believe it. Can't believe what you hear. Test.
You know, third.
You got a pass on the board. I had like a wave this morning, like in the back of my head. They're fighting. So, they were all like, we have a motocross.
Now I'm going to post the answers to the chapter review. Let's get started now. I'm going to post the answers to the chapter review on our Facebook group. So you should complete your chapter review, then check your answers with the answer key that will be posted. A picture of it will be posted in the group, in the Facebook group. Check your answers to make sure you're on the right track so that you're ready for the test next week.
Yes, ma'am.
Okay? We'll have a chapter 1 test next week. So now, let's take a look at page 20. Let's take a look at page 20. You can estimate radicals without a calculator. Now let's take a look. If I have a number line right here, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's see if I need any more than that. No, that's all I need for now. Now, the first one is the square root of 25. It doesn't have, it's an irrational number, isn't it? No, wait, when square root of 25 is not an irrational number. It's 5. Hello. This is the square root of 25, isn't it? 5 is the square root of 25. I'm on page 20. Now 6, let me spread this out a little bit more here. Let's just have 5 and 6 here. This is the square root of 25, and this is the square root of 36, isn't it? So now the square root of 28 will be somewhere right around here, right past 5, huh? Maybe 5.2. What does that look like? 5.1, 5.2? Put in square root of 28 in your calculator now. What is it?
5.29.
5.29 is almost 5.3. But I was pretty close, 5.2. When you're estimating, that's close enough. Stop, please. How about the square root of 30? Now let's take a look. 25 to 30, 30 to 36. 30 is almost right smack in between 25 and 36, huh?
Yes, ma'am.
25, 30, 35, that would make it right smack in the middle, right? But it's just a tad closer to 5 than it is to 6, huh? It's 6 away here. 30 to 36 is 6 steps. 25 to 30 is 5 steps. So it's just a tad bit closer. Now 5.5 is right in the middle. So it's going to be just below 5.5.
5.47.
5.47. You can estimate it at 5.5. Does that make sense? Now let's take a look at the square root of 32. Well, this is 5.5. The square root of 32 is going to be just past 5.5. It's a little bit closer to 36. There are just 4 steps between 32 and 36. There are 7 steps here. What would you estimate, Kaylin, that the square root of 32 would be?
Probably like 7.40 something.
Well, the square root of 32 is going to be less than 6, right? You see, the square root of 25 is 5. The square root of 36 is 6. You see how 32 is between 25 and 36? So the square root of 32 is somewhere between 5 and 6, right?
Yeah.
Now halfway would be 5.5. But look, this is 7 steps here and only 4 steps here. 25, 26, 27, 28, 29, 30, 31, 32. 25 to 32 is 7. But 32 to 36, 33, 34, 35, 36, that's only 4 numbers apart there, right? So you see how 32 is a little bit closer to 36 than it is 25? So it's a little bit this side of halfway, isn't it?
Yeah.
Halfway would be 5.5. So what would be right past halfway? You think 5.6 or 5.7? Were you meaning to say 5.7 when you said that?
Yeah.
I thought that might be what you were thinking. Yeah, you were saying 7 point something. You meant
that's
5.7, huh?
Yeah.
That's what I was thinking. Now put in the square root of 32 and see if it's about 5.7.
I'm pretty sure it's 5.6.
5.6 what? 5.67, which is right at 5.7. You would round that to 5.7, wouldn't you? Now let's take a look, well, square root of 36. So now, let's take a look at number 123. And it says the square root of 19. The square root of 19. Well, the square root of 19 is between the square root of 16, which is 4, and the square root of 25, which is 5, right? So the square root of 19 is right in between these two, somewhere between 4 and 5. Matthew, what would you estimate the square root of 19 to be?
Like
Is it going to be closer to 4 or closer to 5?
in the middle.
Well, look, 19 is 3 steps away from 16, right? It's 6 steps away from 25. You see that? So the square root of 19 is a little bit closer to 16 than it is 25, right? So what would you estimate it to be? It's going to be 4 point something, right? It's not going to be 4.5. It's not going to be halfway. It's going to be just a little bit below 4.5. Maybe 4.3 or 4.4. Something on the ballpark here. Now put in the square root of 19 and we'll see what you get.
0.3
I'm asking Matthew.
No, I made
Oh.
that number up.
0.3 and a half?
It's not. It's
Okay,
not there.
stop.
So 4.36.
4.4. Right between 4.3 and 4.4, right? Does that make sense? Allie, look at the next one. The square root of 41. Now, the square root of 36 is 6, right? And the square root of 49 is 7. So now the square root of 41 is going to be right between 6 and 7, isn't it? The square root of 41, well, it's 5 away from 36 and 8 away from 49. Do you see that? The square root of 41, it's closer to 36 than it is 49, isn't it? So what would you estimate the square root of 41 to be?
Maybe.
Well, is it going to be 6.5 above or below? Halfway from 36 to 49. Let's take a look right here. 36, 37, 38, 39, 40, 41. So it's 5 steps to the square root of 41 here, right? And then 41 to 49 is 8 steps. So it's 5 steps away from 36, and it's 8 steps away from 49. Does that make sense? So you see how it's closer to 36 than it is to 49? So it's going to be a little bit closer to 6 than to 7, right? So it's not going to be halfway. It's going to be right to this side of halfway.
Maybe 6.4.
Probably about 6.4. Anyway, you can estimate 6.1, 6.2, 6.3, or 6.4, and that is correct. So just pick one of them, and you think about 6.4, but any of those is correct. If you put down 6.1, it's going to be somewhere between 6 and 6.5. Now punch it into your calculator and see what you get.
Hold on. 6.6.
Allie? The square root of 41?
6.4.
6.4.
I was at the wrong one.
It can't be 6.6, can it, Allie? Because it's below 6.5, isn't it? So you see, you were right on the money, weren't you? 6.4. Now let's do one more. Cash, the square root of 98. Well, the square root of 9 is 81. The square root of the square root of 81 is 9. The square root of 81 is 9. The square root of 100 is 10. And they're asking us, what is the square root of 98? Now, is that closer to 81 or closer to 100, Cash? So what would you estimate the square root of 98 to be?
9.9.
9.9. You could say anything, 9.6, 9.7, 9.8, 9.9. I would count any of those as correct. It's above 9.5. But 9.9 is probably very accurate. Now put in the square root of 98. Oh, you don't have your calculator. Put in the...
It's 9.89, but I rounded to 9.
Well, 9.89 is 9.9. You see that? Very, very accurate. So, now you have problems 126 to 130 to practice that, to practice estimating it, and then 131 through 138. Now, on the test next week, Mr. Maxwell, you starting to feel a little bit better?
That's what I'm saying.
I think maybe the
Do that.
snacks just need to kick in, huh? Okay, so now let's take a look at number 131. Now I put it in this format because sometimes this is what you'll see. This is how you'll see it on the ACT. Okay, let's take a look at number 131. The square root of 61, Hunter. Which letter do you think that would correspond with? Well, first of all, let's take a look. The square root of 61. Let's see, the square root of 64 is 8, right? So the square root of, and that's below it, so we have to go here. The square root of 49 is 7, right? So then the square root of 61 is going to coordinate with which point on that number line, Hunter?
D.
D is correct, between 7 and 8. So the answer to that one is D. The answer to that one is D. This is number 131. The answer to that is D because it corresponds with D between 7 and 8 on the number line. Does everyone understand that? Very good, very good. So now let's go to page 21. I'm sorry. Yes, page 21. Now we're going to talk about classifying numbers. And I've drawn some little boxes here for you. Okay. Now we have a box. And it has numbers 1, 2, 3, and on and on and on. That is the set of natural numbers. And it is designated by the capital N. The capital letter N. Natural numbers. Noah, tune in right there to your page for me. I'm on page 21. So imagine I have a box, Sullivan. Face forward. Imagine I have a box, and I have numbers 1, 2, 3, 4, 5, 6, on and on and on to infinity. That is the set of natural numbers. The set of natural numbers. 5 is a natural number. 22 is a natural number. -4 is not a natural number. It is not in that set of numbers, is it? So you have to remember when I say set N, I mean 1, 2, 3, and on and on and on to infinity. Now, if I take that box, of natural numbers, and I put it in a bigger box and I throw 0 in there with it, now it's a set of whole numbers. So I take this big box, I throw in the natural numbers, 1, 2, 3, on. I throw all those numbers in that box, and I also throw 0 in that box. Now this is the set of whole numbers. And we call that W, the set W. That's the set of whole numbers. 1 is a whole number and a natural number, isn't it? 0 is a whole number, but it's not a natural number. 0 is in the set of whole numbers, but it is not in the set of natural numbers. Now you're going to have to memorize this. Now, I take this box, within the box, I have my natural numbers in the box with the whole numbers, and I put that whole thing, I need to make it a little bit bigger here, I put this whole thing into a bigger box. So my natural numbers are in with my whole numbers, plus the 0. And then I put all of this into this box, and I add the negative numbers. So now, -5, -4, -3, -2, -1, 0, 1, 2, 3. These are called integers, and we use the symbol Z to stand for integers. You have to memorize these symbols and what they mean. You have to know that an integer is these numbers, negative numbers, 0, and positive numbers. -2 is an integer, 0 is an integer, 2 is an integer. All of these numbers are integers. Okay? But -3 is not a whole number, is it? No. 0 is not a natural number. Okay? Now, the next thing that we do, I get a bigger box. And here, I call this the in-betweens. I'm going to put all of these numbers in here, but now I'm going to add the fractions in between -3 and -2, in between 2 and 3, 2 and 1/3, 5 halves, 4/3, -4/3, -5 halves, -2 1/3. The fractions, the in-betweens. Here we have -3/5, 5/7. Now this includes repeating decimals. What is 1/3? This is an integer, isn't it? And integers, I'm sorry, rational numbers. Hello. Rational numbers. That's why I looked at. These are rational numbers now. Rational numbers. They include the fractions. 1/3 is a rational number. Put 1 divided by 3 in your calculator. What do you get? 0.3 continuous, 0.3 repeating. Repeating decimals are rational numbers. Because any of these, I can tell you exactly where they are on the number line. Even though that's 0.3 repeating, it is 1/3. And I can point to exactly where 1/3 is on the number line. It's exactly 1/3 of the way between 0 and 1. So rational numbers are any number that I can point to exactly where it is on the number line. Any point on the number line. All the points on the number line are the rational numbers. Now, you see over here, I have a new box standing off by itself. These are the irrational numbers. We use P to denote irrational numbers. Now remember, we just talked about irrational numbers. The square root of 11, the square root of 15, not the square root of 16. That's 4. That's a natural whole integer and rational, isn't it? Square root of 16 is an even square root, but 15, 11, those are not. These are never ending, never repeating decimals. Never ending, never repeating decimals. Never-ending, never-repeating decimals. If I have 0.25 ... I can't pinpoint it on the number line because one more decimal place, it moves. One more decimal, it keeps moving, doesn't it? It keeps moving a little bit because it never ends. I don't know exactly where this is on the number line because it never ends. I know about where it is, but I cannot point and say that's exactly where it is because it never ends. So that's what an irrational number is, a never-ending, never-repeating decimal. Pi is an example of a never-ending, never-repeating decimal. We'll learn more about that in geometry, but just understand that pi is one of those numbers. Now, we have rational and we have irrational, but they're all numbers, aren't they? They're all real numbers. They're just rational and irrational. We may not be able to tell you where those irrational numbers are on the number line, but they're real numbers, aren't they? And that's the letter R, usually with 2 lines right there. Real numbers. Now let's go to page 22. Oh, I just have to turn my page over. And you'll see, I'm just going to make it very small right here. Here are my imaginary numbers, huh? Remember, this is the square root of -16, right? It's not real. Here are our real numbers, rational and irrational. These are imaginary. And I is the symbol, a lowercase I is a symbol for one of the imaginary numbers, or the imaginary number, basically. So the square root of a negative number, or I, those are imaginary numbers. They can also look like this: 5 times I, or 3 plus 2 times I. Those are all -3 minus 2I. Those are all imaginary numbers. Now, all numbers, real or imaginary, are called complex numbers. Whether it's real or imaginary, it's called a complex number. Every number, real or imaginary, is a complex number. Now, you're going to have to use this chart to answer some of these questions. First of all, here's some practice. You have to memorize these. On page 22, you have to memorize these. This is why I told you to start that chapter review, huh? Because you're going to have a lot to memorize this week. You have to memorize these symbols. You're going to have to know them. You're going to have to know them for the test. Now, let's take a look at page 23. We're going to check off the boxes that each number of each set that a number belongs to. Let's take a look at -7. -7 is not a natural number, is it? It's not in this box. -7 isn't a whole number either, is it? But -7 is an integer, isn't it? And remember, all integers are rational, all rationals are real, and all reals are complex. So you're going to mark off, check mark for Z. You see where the Z is for integer? Put a check mark in that box, and everything after that. Well, not everything after that. Q, check off Q. Now, of course, you're not going to check off irrational because it's rational, right? But you're going to check off R for real. Now, you're not going to check off imaginary because -7 is not imaginary, but you're going to check off C for complex.
Wait, so we're also
You're not on the right page.
No, I was just going back. I was saying.
Gotcha.
You said we're also.
Are you supposed to be working ahead?
Oh, I'm sorry.
Erase that, please. Thank you.
Okay, that's right. So you.
We're not Xing. Is that what the directions say? only check off, so erase the X's. We're not putting anything in the boxes that it's not. So -7, you should have a check mark under Z. You should have a check mark under Q. You should have a check mark under R for real. And you should have a check mark under C for complex. -7 is in the set of integers. Remember, all integers are in rational numbers. All rational numbers are in real numbers. And all real numbers are in complex numbers, in the complex number box, right? You're going to have to use this chart to practice this. Now, why do I give you so much practice? Because on the test, you're going to have to do it without this box. Now, you can draw this box on your test. These boxes, you can draw them and use that if you want to, but you're not going to be given, no, you see that? You're not going to be given these boxes on the test. So if you can draw these boxes on your test, that's perfectly fine. But you need to memorize how to draw these boxes. Yes, sir?
Are we allowed to use like note cards to write this on it? And like
No.
note cards?
No.
No.
Can
No.
we use it to study?
Yes, you use note cards to study, but you have to memorize this. I need you to memorize this. Because you know what? On the ACT, you have to know this. If you didn't have to know it for the ACT, or you didn't have to know it for college, I'd say forget it. Use note cards. I'll give it to you on a piece of paper. But you have to know it for the ACT. And you have to know it for college without seeing the chart. Now, on the ACT, you can jot out these boxes here. You can sketch out a picture of these boxes on the ACT. That's fine. So you can do it on the test. But you can't have a copy that you bring with you. Because for the ACT, you need to know it. Now, I'm giving you some practice, okay? Because these are the kinds of questions that you see on the ACT. Let's take a look at 3/4. What boxes are we going to check off for 3/4? See if you can figure it out, and then we're going to go through it. Sarah, is 3/4 in this box? 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 Q. Rational numbers. Check marking Q. Is this number in irrational numbers? No. If it's a rational number, it can't be an irrational number. Is 3/4 in real numbers? Yes, because rational numbers are in the box of real numbers. Now, is 3/4 in imaginary numbers, Sarah? No, because rational numbers are not in imaginary numbers. That box is not in that box. This is a separate box. This is a separate box. But rational numbers and real numbers, real numbers are not in imaginary numbers. But are they in complex numbers? Every single one's in complex numbers. You can just check off complex all the way down right now. Just go through and put a check mark in every single complex one. You see all the way down, complex. You can just put a check mark all the way down. Every number is a complex number. Because the set of complex numbers is the set of all numbers in the universe. So every number is in that one, and 3/4 is in rational and real. So now everyone try numbers 149 through 154. 149 through 154.
Which one do you want to stab at again? 54? Alright.
Max, do you have your Algebra 2 homework done?
I'm missing 2 papers.
I can't hear you, look up.
Yep.
Do you have your Algebra 2 homework done?
I don't think I did a couple pages.
You think you did a couple pages?
No, I said I think I didn't do like 4 pages maybe. But I know how to do it. I know that doesn't really excuse it, but I know how to do it.
Gotcha, I'm just letting your mom know.
I told her,
Oh, okay.
but
Okay, so let's take a look now at number 149. Madeline, what did you check off for 149?
I put imaginary and complex.
That's right, imaginary and complex. An imaginary number is only complex, besides being imaginary. Very good. Allie, what about the square root of 2?
I put, I put irrational.
Irrational. And what else besides irrational? Here's irrational right here, right? What box is irrational in besides the irrational box? The real.
The real and the complex.
And the complex. So you should have irrational. It's also real because all irrational numbers are real numbers and all real numbers are complex numbers. So you should have P, R, and C. Nick, what do you think about 0?
R.
Well, let's start from the center. Here's 0 right here. Right? It's not in this box, is it? But it's in the whole number box, so check off whole. Now, wholes are in integers, right? You see, wholes are in the integer box, All whole numbers are integers, right? So check off Z for integers. Now, all the integers are in rationals, aren't they? Everything that's an integer, which is everything that's also a whole number that's an integer, is also rational. So check off Q for rational. And then you had that one. And then all rationals are also real. And all reals are also complex. So you should have W, Z, Q, R, and C. Does that make sense?
So everything except for N, P, and I.
Everything except for N, except for P, and except for I. That's right. Because 0 is not a natural number, is it? And 0 is not a rational number, an irrational number, because it's rational, right? So it's not irrational. And 0 is definitely not imaginary, is it? So it's everything except for N, P, and I. Now we're at the repeating decimal, 0.71 repeating. Matthew Marchese, where do you think that, which ones will we check off there?
Rational,
That's right, rational.
real, and complex.
Exactly, rational, real, and complex. Repeating decimals are not in any of these three small boxes, but they're in the rational box right here. You see the repeating decimals, and rationals are real and reals are complex. They're definitely not natural, whole, or integer. They're not irrational, and they're not imaginary. Very good. Very good. Gabe, how about number 153?
150, I kind of had a hard time on that one.
The square root of 25. Whenever we're looking at square roots, we have to ask ourselves, is it an even square root, like the square root of 4 and the square root of 16? Or is it one that doesn't come out to an even number? What is the square root of 25? Is it a never-ending, never-repeating decimal, or is it a whole number?
It's a whole
Or a natural number?
natural.
Or whole, yeah. Right, the square root of 25 is 5. And that's this one right here, isn't it?
Right. Okay, so it, check
What would you check?
N.
N. N is inside of W. So check W. W is inside of Z. Z is inside of Q. Q is inside of R. And R is inside of C. You see that? But it's not irrational.
Right.
And it's not imaginary. I hate this part of algebra. I do. It gives me a hard time to keep the symbols together and stuff, but you see it very often on the ACT. So if you just take the time to master it, to memorize it and master it, that's one more question that you'll be able to get right on the ACT. Okay, number 154, Zach. 0.35 repeating. I mean, not repeating, 0.35 ... going on forever. Where would that be in here? That means ... means it's never ending and never repeating, huh?
Yeah, it would be P.
That's right, irrational. The never ending, never repeating. It's none of these, Q, Z, W, or N. It's none of those. It's not rational, it's irrational, huh? So it's not rational, integer, whole, or natural. It's none of these in this box here. It's in the P box, irrational. What else is it in, Zach? R for real, because irrationals are real.
And C.
And C for complex, because all numbers are complex. So like I said, you're going to use your boxes to help you practice and memorize this. Okay? But for the test, you've got to either know it or be able to draw your boxes yourself. Because on the ACT, you can draw your boxes. You can do that. Now, let's go to page 24. I give this to you in so many different ways because these are the different ways you see it on the ACT. And what do I want from you out of this class? I want you to be ready for the ACT, and I want you to be ready for college. And the ACT tests you to see if you're ready for college. So if you're ready for the ACT and you do well on the ACT, it tells you you know what you need to know for college, right? And so I look at the ACT, and it's kind of like the guideline. The ACT is the end-all, be-all for what you need for college. And that's why we look at what you need for the ACT. So now, everyone try numbers 166 through 169, the ones that have asterisks by them, and then try 178 and 179.
I have absolutely no idea what to do with 178, 179.
Is Z an element of Q? Is the set of Z?
Oh, I see.
Maxwell, you're not going home with Lucas.
No, so I was going home with Lucas.
Oh, Gabe and Sullivan. I got y'all all mixed up. I'm like, wait a minute, Lucas isn't going home. Okay, Cash. Now, when I say true or false, I want the whole word written out. I don't want T or F. I want the whole word written down out every time. So, Cash, is it true or false that all whole numbers are integers?
Yeah.
That's right, it's true. All whole numbers are in the integer box. You see that? All the whole numbers are in the integer box. All whole numbers are 0, 1, 2, 3, 4, 5, 6, forever. All of those numbers are part of integers. Very good. Hunter, are all integers natural numbers?
No.
That's right. You see, natural numbers are integers, but integers aren't necessarily natural numbers. -3 is an integer, and it's not a natural number. You can't go smaller like that. All integers are not natural numbers, so that's right, that's false. Matthew, are all rational numbers real numbers? That's true. All rational numbers are real numbers. Zach, are all complex numbers rational numbers?
True.
All complex numbers, are they all rational? Some of the complex numbers are irrational. Some of the complex numbers are imaginary.
Oh, false.
Yeah, that's right. Very good. All complex numbers are not rational. Some of the complex numbers are rational, but some of them are irrational and some of them are imaginary. Okay? Now let's go to 178. Is Z a proper subset of Q? Is Z a proper subset of Q, Kaylin? Is Z part of Q?
Yes.
That's true. That's right. Z is part of Q. Okay, Z is part of Q. Nick, is I a proper subset of W? Are imaginary numbers a proper subset of whole numbers? Is this set of imaginary numbers part of whole? That's false. That's correct. That is false. That is false. Now, let me review something right here. Here I have the set of 1, 2, 3, 4, 5, 6. Okay? So 4, 5, and 6, the set of 4, 5, 6, let's say this is set A. Set of 4, 5, 6, this says set of 4, 5, 6 is a subset or equal to A. And that's true because 4, 5, 6 is a subset of A. Okay? 1, 2, 3, 4, 5, 6. This is also true. 1, 2, 3, 4, 5, 6. It's a subset or equal to A. A subset or equal to. This is not true. 1, 2, 3, 4, 5, 6 is not a subset, a proper subset of A. Because a proper subset is only part. Okay? So this is not true right here. 1, 2, 3, 4, 5, 6 is not a proper subset of A. Because it is not part. That's true. 1, 2, 3, 4, 5 is a proper subset of A. It is part of A. Does that make sense? Okay? So remember, this symbol means it's a subset or it's equal to. It's a subset, it's a proper subset, or it's equal to. This is just it's a proper subset. We don't say proper subset, we just say subset here. Here, we say proper subset. But what this means is a subset or equal to. This is just part, not equal to. Does that make sense? Now, let's take a look at, did I lose a page here? Thank you. So we finished 24. Let's take a look at page 25. What I want you to do is I want you to draw a set of boxes. Just like I've drawn here, just like I have drawn in your book. I want you to draw that set of boxes. You can go to page 22 and trace that one, except you don't have them all in there. But I want you to draw a set of boxes, and I want you to place each one in the proper box. Let's do a few of them. I have the boxes drawn up here. Where would the square root of 3 go, Sarah? Where would I put the square root of 3 here? In which box? In irrational. That's right. I would put it in this box, which would make it in this box and in this box. This is where I would put the square root of 3. Very good. It's irrational. And it's real and it's complex. Where would I put the number 2, Madeline?
And natural.
In natural. 2 would go here, which is 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 here. Right? Very good. Allie, where would I put negative 1/5?
You would put it in Q.
In Q, in rational numbers. Here has negative numbers, but not fractions. Not the in-betweens, just the negatives. You're right, it would go in Q because it's one of the in-betweens. And Q is in R is in C, isn't it? Right? Okay. Maxwell, where would I put 7I?
Imaginary.
I would put it in this box way over here in the imaginary box. Very good. Sullivan, where would I put -6?
Q. Irrational. Oh, sorry. Z.
These are the negative numbers right here, right? Integers. -6 is an integer. It's also a rational, a real, and a complex. Because this box is in this box, is in this box, is in this box. Okay? But it would go one step closer in. Gabe, the square root of 36. That's what you got the last time. No, you got the square root of 25 last time.
Yeah.
Where would the square root of 36 go? Well, check and see. Whenever you have a square root, a radical, you check to see. Does it go here or here? Does it come to an even answer? You know, a whole number, a natural number answer?
Oh, natural.
That's right. Natural, you put it in the natural box, which would then put it in the whole, the integer, the rational, the real, and the complex. So you will continue to go through and put each of those numbers where they go. Now let's take a look at page 26. Here are 3 questions straight from the ACT. Who wants to try their hand at that? Which group of numbers contains no rational numbers? See if you can figure out which of those groups has no rational numbers. Maxwell, what do you think?
B.
Say it again.
B.
B. 4. 4 is not rational?
No, that's right.
-1/5? What do you think, Madeline?
C.
C. The square root of 23. Let's take a look at that. The square root of 23. Now it's a square root. Does it go here or here? It goes irrational because it's not an even square root. It doesn't come out to a whole number. So that one's irrational. -5.12 ... Never ending, never repeating. That's irrational. 5I, that's imaginary. That's not rational. So we have 2 of them in this box and 1 of them in this box, and none in this box so far. 7 minus 3I, that's also an imaginary number. So C is the correct answer. Now, note 193, I changed it a little bit because you always have multiple choice on the ACT. But which of the following numbers are irrational? Circle the numbers in that group that are irrational. Noah, what's the first one that you circled? I'm sorry, what? What question number are we on?
Oh, I was still doing first
We already gave the answer to that one. And it wasn't B. So you having trouble staying tuned in? We're on question number 193. Cash, what's the first one you circled there? Pi, that's correct. Pi is the first one. Nick, what's the second one you circled?
5.32.
5.32 dot dot dot. Very good, very good. Zach, what's the next one you circled?
0.72.
0.72 repeating. Is a repeating decimal irrational?
Yeah.
Look where repeating decimals are.
Oh, yeah.
That's the one that gets me every time, Zach. No, do not circle 0.72 repeating. Don't circle that one. Repeating decimals are rational. Remember, we know exactly where 1/3 is on the number line.
I didn't even notice the little line above 72.
Oh, okay. So Noah, which one did you circle next? Noah, why is your book closed? Which one did you circle next?
Maybe 7 plus 4i.
7 plus 4i. There is another one before that, but that is an irrational number. Very good. I want you to keep your book open until we're done. Who sees one more? Solomon?
0.
Is 0 irrational?
No, it's whole.
0.891.
0.891 decimals. 0.891 is rational. 0.891 is rational. Sarah? 5i.
I just asked him. I said, "Did we already say 5i?" He said,
Well, you should have been tuned in to know.
5i is imaginary, not irrational.
5i is, wait, hold on. What are our questions? Which of the following numbers, I'm sorry, are irrational? Not 5i, I'm sorry. Thank you. Not 5i. I'm thinking with the last question, I'm like with Noah, I'm going rational. Not 5i. 5i is imaginary. Which ones are irrational? Pi is irrational, so circle pi. 5.32 dot dot dot, circle that one. That one's irrational. And not 7 plus 4i. That's imaginary. I was getting my question mixed up. Not 5i. That's imaginary. The only ones that are irrational are pi and 5.32 dot dot dot. I'm sorry, y'all. I was getting confused on my question. Okay, and y'all can work on 194. So now, you're going to complete through page 33. Anything you haven't done through page 33. You will have a chapter 1 test next week on everything in chapter 1. Now remember, the review answer key will be posted in our group, in our Facebook group. Send me a message. If we're friends on Facebook, send me a message to include you. If we're not friends on Facebook, you're going to have to send me a request. Sorry about that. I just couldn't figure out another way. See you later. I want everybody to have all this written down. Okay, if you can do the review, you can do the test. But you will have to memorize the things I said to memorize. Part of the test will be to complete the memorization parts without a calculator.
So, like, I knew what to do on the test, but my mind drew a blank when it came to